Hello everyone, my name is Akash Deshamke and I am excited to share my internship journey in embedded system development. During this internship, I work on programming the PIC16F877A microcontroller using embedded C, and I explore circuit design and simulation using PIC As a part of my final project, I develop a washing machine simulation. This project demonstrates how basic functions of a washing machine like start or stop, control, water level indication, motor operation and buzzer alerts can be simulated using components such as LEDs, switches and timers, all controlled by the PIC16F877A microcontroller. Through this project, I gained practical experience in microcontroller programming, simulation based testing, and system automation. In this video, I will walk you through the circuit, the logic behind the code, and how everything comes together in simulation. Let's get started. Let's see the overview of internship. This internship was about learning how to build small electronic system using a microcontroller and programming it using embedded C language. We work on real-time mini projects and understood how sensors, LEDs, switches and displays work together with code. The goals of internship are to understand what embedded systems are and how they work, to learn how to write programs in embedded C for microcontrollers, to connect and control devices like LEDs, buzzers, switches, and displays, to practice building and testing circuits using simulation software like PIXimLab, to write and upload code using MPLAB ID and understand how it helps in programming microcontrollers, to complete a mini project by applying everything learned during the internship. Introduction. Washing machines are used to reduce human labor and save time. It provides water and energy efficiency due to its advanced technology in newer models emphasizes water and energy conservation, making washing machines environmentally friendly and cost effective in the long run. It is convenience and automated with programmable features and automatic cycles. Washing machines provide unmatched convenience, allowing users to set and forget, freeing up time for other activities. It gives space-saving design due to available in range of sizes and configuration including stackable and compact options. Washing machines are designed to fit seamlessly into modern living spaces, optimizing utility without sacrificing room aesthetics. What is embedded system? An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a large system. In this diagram, we can see that there are input variables, output variables, user interface, and link to other devices. The middle block of diagram is a embedded computers block diagram which consists of software and hardware. This diagram represents the basic working of an embedded system. It receives input variables, example sensor data, processes them using the internal hardware and software, and generates output variables, example actuator control. The system also includes a user interface for human interaction. Additionally, it can connect and communicate with the other system. The types of embedded system are mobile embedded system. In mobile embedded systems are embedded in mobile phones and cameras. Second, standalone embedded system. In standalone embedded system, work by receiving the input without using any ghost system for desired outputs. Third, real-time embedded system. Real-time embedded system are designed to perform a specific task with a time frame. Network embedded system. Network embedded system are usually general purpose processors. What is embedded C? Embedded C is a programming language that is used in the development of embedded system. Embedded C is used to program a wide range of microcontrollers and microprocessors. Embedded C allows us to work with hardware devices like sensors and input-output devices. There are various embedded C compilers to compile the embedded C programs such as Keel compiler, SVJ compiler, embedded JNU C compiler. What is keywords in C? A keyword is a reserved word in a programming language that has a predefined meaning and cannot B. Used as an identifier like variable or function name. The sum of the examples of keywords are auto, default, float, register, struct, volatile, break, do, for, return, switch, while, case, double, etc. Data types. Data types in C. A data types defines the type of a data a variable can store in a programming language. It tells the compiler how much memory to allocate and what kind of operations can be performed on the data. Data types are mainly classified in primitive and derived. Some of the examples of primitive are integer, character, float, and double. Some of the examples of derived data type is array, structure, union, enum, and pointer. What are the operators? Operators are used in a C to perform a specific computations. Example types of operators are assignment operators, arithmetic operators, relational operators, logical operators, bitwise operators, size of operators, conditional operators, and comma operators. The conditional statements. The conditional statements, also known as if then statements, are fundamental in programming and logic. They allow to program to execute different blocks of code based on whether a certain condition is true or false. Types of conditional statements are if else, true false, and switch. PIC16F877A microcontroller. PIC stands for Programmable Intelligent Computer. Earlier it is known as Peripheral Interface Controller. It is a type of microcontroller made by Microchip Technology. First developed in 1993 by General Instrument. It comes in 8-bit, 16-bit and 32-bit version. It is based on the RISC, Reduced Instruction Set and Howard architecture. It can be programmed to do many tasks like controlling LEDs, motors, sensors, etc. The PIC16F877A has total 5 ports. This port A contains 6 pins. Port B contains 8 pins. Port C contains 8 pins. Port D contains 8 pins and port E contains 3 pins. It has total 33 programmable pins. And among these, it has 8 ADC pins, 2 PWM pins, 2 I2C pin, 3 SPI pin, 2 UART pins and external interrupt pin. To program PIC16F877A, programming the PIC16F877A involves writing code in assembly language or using the high-level programming languages such as C. Microchip provides the MPLAB IDE integrated development environment to facilitate the development process. MPLAB supports both assembly and C language programming, offering a user-friendly platform for writing, compiling, and debugging code for PIC microcontrollers. The assembly language for PIC microcontroller is specific to the architecture and requires an understanding of the instruction set. On the other hand, using C language simplifies the programming process, making it accessible to a broader audience of developers. The availability of robust set of libraries and the tools further streamlines the development of applications for the interrupts. The PIC16F877 supports several type of interrupts including external interrupts. It is triggered by external signal applied to specific pins of the microcontroller. The PIC16F877 has several pins designated for external interrupts. Timer interrupts, generated by built-in timer module at specific time intervals. These are useful for tasks requiring precise timing. Peripheral interrupts. It is triggered by an internal peripheral such as USART, SPI, or I2C modules upon the completion of specific operation. Software interrupts, triggered by software instructions rather than the external events. Timers. PIC16F877 has a 3 timers. Timer 0, which is an 8-bit timer. Timer 1, which is as an 16-bit timer, and timer 2, which is an 8-bit timer. Peripheral devices. First, LED. LED stands for line emitting diode. A light emitting diode is a semiconductor device that emits light when current flows through it. In this code, we can see that we have turned on all the LEDs of port D and off and turn off the all LEDs of port B. Second, CLCD. The pins available in character LCD module includes power supply and ground that are VSS and VDD. Contrast adjustment, which is known as VO. Control lines like RS, RNW, and E. RS stand for reset, RW for read and write, and E for enable. Data lines are D0 to D7, and backlight connections are A, K. Most commonly used display ASCII characters. Some customization in symbols possible. Communications mode are 8-bit mode and 4-bit mode. Keypad. A digital keypad is an input device consisting of a grid of push buttons arranged in a matrix format, typically used for entering numerical or alphanumeric data into electronic system. It is commonly found in embedded system, security systems, and consumer electronics. Design. A standard digital keypad is designed using a matrix of rows and columns. Each key press connects a specific row and column, allowing a microcontroller to detect which button is pressed through scanning. The most common configuration are 3 by 4, which has 12 keys, and 4 by 4, which has 16 keys. The working principle behind the keypad is when a key is pressed, a connection is made between a specific row and column. The microcontroller continuously scans the matrix, identifying the active row column intersection to determine which key is pressed. This setup reduces the number of input output pins needed. Software MPLAB ID. Uh, for programming, we use MPLAB ID. MPLAB ID, which is an integrated development environment IDE used for the programming and debugging microchip PIC microcontrollers, including the PIC16F877A. Here is a brief overview of using MPLAB IDE for programming PIC microcontrollers. PIC is a real-time emulator of PIC microcontroller. It provides a graphical development environment where you can write, debug, and simulate programs for the PIC microcontroller. Project simulation in PIC Let's see the project simulation in PIC Firstly, we have to open the MPLAB IDE where our program is written. To program to compile it, we have to press clean and build the main project. We can see that our program is successfully compiled. After that, the successful compilation of the program, we get the address where our hexadecimal file is located. In this program, we can see that we have included the 4 header files and 5 main files, 5.c files. So let's go to the MPLAB PICSIMLab for the rest of the work. This is the interface of the PICSIMLab where we have chosen the PIC16F877 microcontroller. We can see that there is an LCD, CLCD at this. This is a fan, or we can also call this as a cooler. This is a buzzer. This is the PIC16F877 microcontroller IC. These are the keypad, and these are the LEDs or indicators. To program, firstly we have to upload the hexadecimal file in the microcontroller. Let's load the hexadecimal file. We have to simply copy paste the address copied in the MPLAB ID in this search bar. After that we get the hexadecimal file. We simply open it. After that the code is uploaded in the PIC16F877 microcontroller. Firstly, this is the switch 0, switch 1, switch 2, switch 3, switch 4 and switch 5. To turn on the machine, we have to press the switch 5, which is this. We can see that there is a window where the power process is done. we are in the mode that there are washing programs are saved. To scroll it down, we have to press the switch 4. Let's select the one of the program. We are selecting the bed sheets. To get into the program, we have to press it for the 10 second. Then we are in the mode where we have to select the water level. To select the water level, we have also can scroll it down. Let's select the high. To get into the level, to get it to select it, we have to press it for 10 seconds. Let's press switch 5 for start and switch 6 for stop. If we press switch 5 and if the door is open, the buzzer gets on and the process will be stopped. Let's wait for some time. First washing is done. After the successful of the program, we get the notification that remove clothes. Let's select another one. Rinse plus dry. To get into the program, we have to press it for 10 seconds. Let's select the water level. For maximum, press switch 5 for start. The process is started. First rinsing is done. Then spinning is done. After that, we gave display at that the remove clothes. Let's select another one. Daily. Press it for 10 seconds. Select water level as medium. Press switch 5 for start. We can also pause the system by pressing 6 and for starting we can press 5. Rinsing process has started. Spinning is process is started. Conclusion. After the successful completion of this internship, This training gave us a strong foundation in C programming and embedded C. We learn how to write a code using PIC microcontrollers and work with real-world hardware like buzzers, LCDs and sensors. We have used tools like MPLAB IDE, PICSIMLab and help us to build and test project easily. The internship improve our coding skills, hardware, understanding and confidence to create embedded projects on your own. Thank you.